Hello, welcome. We are in chapter 6, and in this video we're going to start lesson 6.6. And in lesson 6.6, our goal is to be able to solve a polynomial. Now, there's a lot of steps in this process, so we're actually going to break this lesson up over 4 days. So there will be 4 videos to kind of walk through all the different steps of this lesson. The first thing that we're going to start with is finding what we call the zero of a polynomial using a graph. And if you remember, when we talked about solving quadratics in chapter 5, we talked about this word zero. And really what a zero is it's the same thing as a solution to our equation. So when we're finding zeros, we are finding solutions to our equations. Now, when we do that on a graph specifically, we are going to find where the graph crosses the x-axis. So anytime we want to find a zero, we're just going to look for where that graph crosses the x-axis. Now, today we aren't even going to really find the specific numbers. All we're going to do today is we're just going to give how many zeros we see. So really all we're doing is just looking at how many times does this graph cross the x-axis. Now, we could graph these by hand. That would take a lot of work. So we're going to use Desmos to help us with this. So you're welcome to pause and pull up Desmos and graph these along with me to make sure that we know how to do this. All right, I'm just going to pull up Desmos on my iPad here, and we'll go ahead and look at the graph of our first equation. So you can see I have all of these equations already typed in, and we'll go ahead and look at the graph of our first equation. Taking a look at this, again, we're paying attention to where this graph crosses the x-axis. And I can see here that it would cross at 3 points, right? I can click on those and we could actually find those numbers. Today, though, we aren't even concerned about those numbers. We're just concerned with the fact that it crosses at 3 different points, which means this graph would have 3 zeros or 3 solutions. If I were to sketch a graph, my graph looks something like this when I look at Desmos, and I see that it crosses at 3 different places. So this graph would have 3 zeros. All right, we'll go ahead and take a look at B, our next equation. So I'll look at x to the 4th minus 3. And again, if we look at for where it's crossing the x-axis, I see there's 2 points there. And again, we don't care about those numbers today, just the fact that there's 2 of them. So if I were to sketch this graph, it looked something like this, and it crossed at 2 points, which means this graph would have 2 zeros. We'll take a look at C. That's going to be this. Now, here we know with this graph that it doesn't cross the x-axis at all. I could zoom out a little bit just to check and make sure that that is in fact true. And it does not cross the x-axis. That means that there would be no zeros for this graph. So when I sketch my graph, I see that it doesn't cross at all, so that would be none. And lastly for D, this is what my graph looks like. I can see that it would cross the x-axis at 4 points, and so that means it would have 4 zeros. Again, if I sketch my graph looking something like this, what we care about is it crosses at 4 points, so that would be 4 zeros. Now, that might seem pretty simple. Again, that's going to be one step of the process that we work through throughout these next few videos. So that's just one part of it. Now, we're going to make some observations here, and that's going to be comparing this long division problem to this graph. So I'm going to go ahead and review long division. Long division is going to be a part of our process, so we do want to be familiar with the steps of long division. I'm going to set up my long division problem. So the polynomial that comes first is going to go under my division sign, and the polynomial that comes second will go outside. With long division, we are always starting with our first terms. So I'm going to watch this x and x cubed, and our process is factor, multiply, subtract. So I'm going to start by finding the factor. What would I need to multiply x by to get x cubed? That would be x squared. Then we multiply. X squared times x is x cubed, and x squared times -3. Remember to also multiply by that -3 is -3x squared. We're subtracting. Subtracting means we're going to change the signs. And then we'll combine x cubed minus x cubed is 0. -2x squared plus 3x is just 1x squared. And we'll bring down the -2x. And we'll repeat that process with our x squared. So I'll look and I'll see what do I need to multiply x by to get x squared, and that would be just 1x. We'll multiply. X times x is x squared, and x times -3 is -3x. We're subtracting, so I'll go ahead and change the signs on that second polynomial. X squared minus x squared is 0. Those will go away. -2x plus 3x is just 1x, and we'll bring down the -3. We'll do this one more time. What would I need to multiply x by to get x? Well, that would just be 1, so I'll just put a 1 up top. 1 times x is 1x, and 1 times -3 is -3. We're subtracting, so I'll change these signs, and we should notice that these will cancel and we'll be left with 0. What that means is this would be my answer. So we'd have x squared plus x plus 1. We don't have a remainder, so that would be the result of our division. Now, what we want to take away from this is actually what we compare to number 2. So I'm going to go ahead and graph this equation on Desmos. So if we graph this equation on Desmos, this is what our graph looks like. What we notice is it crosses the x-axis at one point. And here we're actually going to pay attention to what that point is. This graph crosses the x-axis at the point 3, 0. So when we sketch this graph, it looks something like this. And it's crossing the x-axis, and we notice it crosses the x-axis at 3, 0. Now, here's kind of where I want us to notice some certain things. One, what we notice is this polynomial is the same as this polynomial. So the big polynomial that we were doing our division with is also the polynomial that I graphed. The key here that I really want us to notice is this number and this number here. What we see is that this graph crosses our x-axis at 3, which means 3 is a solution. So x equals 3 is going to be a solution to our polynomial. X equals 3 is a solution to this polynomial. And what we notice is when we had a 3 here, and we divided, we got a remainder of 0. What we were actually doing was we were taking this number and we were writing it as a factor. So what we get is x minus 3 is actually a factor of our polynomial, meaning that if we divide it, we're going to get 0 when we do that. We should not get a remainder. There's something that we see as a pattern here between what we're going to call solutions and what we're going to call factors. And that is that we can take a solution and write it as a factor, factor, and if we divide, we should get 0 as a remainder. So this box down below kind of summarizes that idea. On a graph, our solution is going to be where it crosses the x-axis. So I'm going to say on a graph, solution is on the x-axis. When we're dividing, we should get a remainder of 0. So we're going to say when we're dividing, factors give us a remainder of 0. And we know that we can take these solutions and we can write them as factors. So for example, if my solution was 3, we could write it as a factor, x minus 3. So I'm going to say x minus our number, whatever that number is. Now, the thing that we just have to remember is our factors are always opposite. So we noticed up above, my solution was 3, but our factor was x minus 3. So even though it was a positive solution, our factor we wrote minus. So when we're writing factors, it is always going to be the opposite sign. Now, we're not going to do too much more with this observation today, but this is going to be really important as we continue on solving polynomials. So the last thing we're going to do with this lesson is we're just going to practice writing some equations if we're given the factors. So we have here some factors, and what we're going to do is we're actually going to write the polynomial for those solutions or for those zeros. We're going to give it in two forms. One is called factored form and the other is called standard form. Now we've actually done this with quadratics before, so if this process looks familiar, it's because we did it back in chapter 5. We're going to start with our zeros, our solutions, and we're first going to write factors. We just have to remember that factors are opposite. So if I have a -2, we could write x plus 2. And if we have a +4, we could write x minus 4. Now, to get to standard form, we're actually going to have to multiply these factors. So I'm going to say to get to standard form, we're going to have to multiply, and that's going to be using either distribution or box method. So we did learn this earlier in chapter 6 of how to multiply polynomials. It does not matter to me which method you use, whether you use distribution or box method. I'll go ahead and do distribution for this first one. X times x is x squared. X times -4 is -4x. 2 times x is 2x. And 2 times -4 is -8. We would then just need to combine our like terms, and that would give us -2x minus 8. That's going to be my polynomial, and that would be standard form. All right, we'll try another one. Factored form. Again, we're just taking the opposite. When we have 0, the thing that we just need to note is that adding 0 and subtracting 0 doesn't really change anything. So when I have 0 as a factor, I'm really just going to write my factor as x. You could write +0 or -0, but again, that doesn't really change anything, so we don't have to write that. The -2 will become x plus 2, and the +3 will become x minus 3. And again, to get to standard form, we're going to have to multiply these three things. The thing we want to remember, though, is we can only multiply two things at a time. So I could start, for example, by multiplying x times x plus 2. But I can't do FOIL or box method with all three of these things. So I'm just going to start with 2, and we'll do x times x plus 2. If we do that, I'll distribute the x to both of those things. So that's going to give me x squared plus 2x. After we do that, I can then take and we'll multiply by the third thing, which would be x minus 3. So I'll take that answer and we'll multiply by x minus 3. And again, you could use distribution or box method, whichever one you prefer. I'll go ahead and set up the box for this one just because we've been doing a lot of distribution. But if you want to try it by distribution, feel free to do so. Just make sure you get the same answer. I'll be multiplying x squared plus 2x times x minus 3. X squared times x is x cubed, and x squared times negative 3 is negative x squared. 2x times x is 2x squared, and 2x times negative 3 is negative 6x. Inside our box, we'd be allowed to combine the x squareds. And we just want to make sure, again, we're writing in standard form, so it should be highest exponent to lowest. So my highest exponent is x cubed. 2 plus negative 3, we can always be adding, so 2 plus negative 3 would be negative 1x squared, and then minus 6x. That would be my answer. All right, final example. Here, again, we have 3 zeros, so we'll go ahead and start with factored form by doing the opposite. We have a negative 5, so we'll do x plus 5. Negative 1 will be x plus 1. And positive 4 will be x minus 4. Again, to get to standard form, we're going to have to multiply, but remember that we can only multiply two things at once. So I'm going to ignore that x minus 4 to start, and we're just going to multiply these. Again, feel free to use FOIL or box method, whichever one makes more sense to you. I'll go ahead and start with distribution. So I'll do x times x, which is x squared. X times 1 is just 1x. 5 times x is 5x, and 5 times 1 is 5. Combining like terms, that will give me x squared plus 6x plus 5. Now, we still have to multiply by this third factor here, so I'm going to bring down that x minus 4, and we would have to multiply, again, doing distribution or box method. Since this one has 3 terms, I'm going to go ahead and set up a box, just because once I get to a trinomial, I like the box to help me stay organized. So I'll go ahead and set up a box for this one. I'll put x squared plus 6x plus 5, and then x minus 4. And we'll multiply x times x squared is x cubed. X times 6x is x squared. X times 5 is 5x. Negative 4 times x squared is negative 4x squared. Negative 4 times 6x is negative 24x. And negative 4 times 5 is negative 20. As we take out of the box, we'll write in standard form and combine like terms. Standard form will start with x cubed. Negative 4 plus 6 would be 2x squared. Negative 24 plus 5 would be negative 19x, and then minus 20. And that would be my polynomial in standard form.